Hello everyone, welcome to a new tutorial on Grasshopper and Rhino. Today we will continue with the TOPO Kit tool available in the Land Kit plugin for Rhino and Grasshopper. We have already previously um, presented some of the LandKit tool capabilities, especially the Topo Kit. Today we're going to continue doing topographic designs, but we are going to use features, specific features to modify the topography. Just to remind you, you can find plenty of information, data sets, and the kit, and even more information on different tutorials in the campus home in the Land Kit website. So I recommend you to have a look at this. Um, it has a lot of plenty information that you may find very useful to dig in. So today we're gonna do again a topo mesh, and we're gonna modify this topo mesh using walls and curves. And also I will introduce some of the concepts of using breaklines and spots, and also other features to modify your topography. So I first to introduce, I will show you the Rhino file that I have here, and I will describe briefly all the layers that I have created. Just let me organize these things here properly. So I created a main layer called Topo or Topography, and another layer called Features or Fits in this case, just to make it shorter. It's much easier when you're trying to use the geometry pipeline, or when you want to use panel tools to connect with your topography. So inside the topography, we have different features already there. The contours, we already done that. We have boundaries. This is something new I will show you. We have break lines. We have spots, other geographic. Okay, so we don't need these two. When we show you this, we're going to turn off everything, so you have a better idea of what we have in the topography layer. So the first one is the contours. That's obvious. The second, this boundary will define the limits of your calculation. Let's imagine you have another curve, and I will design another curve in the contours. And if you don't set up any boundary, it will include this in the topography. I will show you. Then we have breaklines and spots as well. So let's turn on everything from now, and let's create our topo mesh. So let's go to the Topo Kit tool. Now we do it different. Before we were doing it through the add to geodata geoset, sorry, add to geoset. Um, this has a geoset, contours, spots, breaklines, meant lines, boundaries, exactly the same information you have here. But there is a way to create this faster, which is just create geoset. If you add this and then you put the name of the whole layer, it will grab all this information into the geoset. And you don't need to add individually. So let's put here a panel. Um, and in the panel, just type topo exactly as it is in your layers. And let me do something here. Okay. So you have grabbed all this information, and then you can have here, you have another button, which is the refresh. It will help you every time you do a change in your topography to change your topography, your mesh. So let's put a toggle, Boolean. Um, we can put a refresh button. So it's just a toggle, but mm, no, sorry. Um, the name is, it should be here, parameters. It's a button, just a simple button. This will help. Okay. So every time we click this, it will refresh. After create your data set, you already grab all the layers. So all the boundaries, the spots, contours, etc. So what we're gonna grab here is just the, we're gonna go to topo, and we're gonna put draw here. create topo. So with the create topo, we'll grab this information, we plug it there. We can use Control Q to disable the preview, and then we're going to put draw topo, correct? So we're drawing here the topo. As you can see here, the topography has been drawn. If we go to perspective, you will see all the information there, all the points and all the mesh that has been created using these points, as you can see here, and using the information that we added here. Now, as you can notice here, there is a contour, which is outside of a boundary. So if you go to boundaries and turn on off the boundaries, that's obviously not affecting the generation of the topography. Let's put here a mesh to make it easier. Sorry, mesh. Let's connect the mesh, and then we disable this. So if we enlarge this boundary, notice that the topography hasn't changed because we haven't clicked on the refresh button. So we just click refresh, and you will notice this will be automatically incorporated. If we change the height, again, nothing is changing. We need to put the refresh, and then you will understand it. So this is how this these boundaries and the toggle or the bottom to refresh is working. So we don't want this, so we just can put it back, refresh, and then this automatically will be out of the calculations, the topographic calculations. Having done this, so what we could do is, instead of having this mesh display, we could add a contour tool. You can always go to display and draw and show the icons if you want that. If not, we just use the names. It's easier for you to find the name of the item we're using, and then we just put the shape there. Obviously, there is nothing here draw because we need to create a distance for the contours, and then we can just disable this if you want, and then we can put a custom preview and a color swatch to visualize this. So then you have the topography. This will help you, these contours, to visualize better the, let's say, relief of your topography, and then perhaps modify some elements there. They are looking a bit awkward, like this point. As you see, nothing is refreshed, so you always have to click the refresh button. Then move it again, refresh. As you see here, the topography is modified using these elements. Okay, so that's very clear. Now, the break lines, as you can see here, these this draw topo has also other variables that are you can also use to modify the topography, which is the minimum number of divisions, the maximum, and the angle tolerance. So you can put an angle tolerance of 1, but sorry, 0 0.0, 0 0.5, 1.0. And so you can put an angle of tolerance if you want to use that tool. Maximum number of divisions, let's put this. And as you see, it's modifying, and minimum number of divisions. So then it's where you can start increasing these numbers, and the topography will change in terms of resolution. And you can see here at least 1, 2, 3, 4, or maximum. Always keep the maximum higher than the minimum. Okay, so what you see here is that, let me move this thing. In this part, the mount is not properly doing a curve, let's say a curvilinear shape. So you can add this sort of break lines if you go to this layer and go to the top view or go to the perspective, and then you can add with a simple polyline of 2 points and add here lines that will help to create a curve or a more curvilinear shape. Okay, and now we put refresh. So you see the topography has changed because you are forcing the topography to follow those break lines. So this is a good way to add extra capabilities to the modification of the topography. Let's do the same here, and you will see that when you refresh it, the topography is changing. Okay, so this is what we got in terms of creating a mesh. Okay, let me organize these things properly so they are clear. So now the next step is just to create all these features, which is a wall and spots and curves. So I already have the walls draw here. If you allow me to show you here, there is a layer where I want to, if you go to the top view is the best way to visualize them. I want to create this wall along this area. Um, Let me reduce that. So here you have the walls. So you need to have the back and the front of the wall defined as a curve. This is another polyline, okay? Defining, can be one or multiple lines, but basically this defines how the length and how will look the wall. And then you have spots, and these spots, for in the case of the wall, if we go to the perspective, it corresponds to the heights where you want this wall to start and where it wants to finish. Notice that these ones are defined in the bottom part, and these ones are defined in the upper part of the wall. Okay. You can play with creating different sort of arrangements and heights, but I already place all this set of points. And remember, if you are, for example, all these points, internal points are defined in the bottom part, you need to have them all aligned at the bottom, and these ones are defined in the upper part. So they're all aligned. So if they start messing up with these points, then you will see what happened. We will do some experiments, okay? The same with the curves. I created just two lines. If you go to top, you will see that they are properly aligned. Now you can use the OSNAP to just stick it to the wall exactly where you want, or you want to put them close to each other, and then we can use some tolerance to define which point and which line will be considered as a wall. So I will explain that when we open we create the geometries. So once we have identified this, or we have drawn all the walls and curves we want to create, we just have to create geometry pipeline for each of them. So the first, I'm gonna copy this. The first one will include a layer called for the walls, another one for the spots, and another one for the curves. So the good thing of this is that you can create just one layer of the spots, including curves and walls, and then it will be automatically work for both. Um, Here we need to click on first the fits um, double, and then we just click on walls. So notice how I typed this to match the layer and the sub layer. Okay, so we can copy this. The second will be spots, and the third will be curves. So we have already our geometric pipeline, but we need to identify what is the type of information they are collecting. So in this case, our points, it collected the points, and notice it disappeared the sort of notification or alert. Now here we're collecting curves, and here we're collecting curves. You can collect also B-reps and other things, okay? So when we have done that, we can add the create walls. We go to create a wall, where it is, create wall. So the first thing we need are the curves that define the wall. So we already have them, we just add them there. And we need the spots that define the bottom part, and the upper part, or the top or the bottom elevation of the wall, as it says here. So we just plug that there. Let me put it in perspective. So nothing has been drawn yet, obviously. Then we can put a curve tolerance and a spot tolerance. That is the distance between the curves and the spot in plan that will determine that this wall exists. So in this case, we can put a curve tolerance of, let's say, 3 meters. It's in relation to your unit. So if you have to go to tools or options, always check the units. If you're using imperial or metric, etc., you need to be sure. So be careful with that, because if you can put 3 feet and then it doesn't work. So that means that beyond 3 meters, these lines, they are apart. They are not going to be part of a wall. You can, for example, try moving this farther, not in elevation, but in distance. And then automatically, because they are more than 3 meters, these lines will not be part of a wall. So obviously, the best is just to put in decimals. So you can put 0.5 if you have walls up to 0.5, or you can put 1.0 meters. Okay. I recommend you to, oh, sorry, that it is for the curve tolerance. So you can work with 0.6. So if you know that they are, look, start appearing and disappearing. Okay. So let's keep it in 3. That's what we know. And then we can put the spot tolerance, something similar. Maybe you can use a decimal or 0.2. And the same will happen. If the point increases or decreases, it will be considered part of node of the wall. Okay, so let's move this one here. So once we have drawn the walls, now we can draw the curves. So now we can create curves. And we follow the same process. We add the curves, we add the spots, and we can get a tolerance here, and then also spot tolerance. So then they are draw our curves. Okay. Now, what we could do in order not to, we can generate or we can draw these elements separate, or we just can connect them and merge them. So we could draw walls here, connect the walls, and automatically disable this, so it's easier for you to see how the walls are drawn, and also curves, and connect to the curves. So now they have been built, as you can see here. If we preview again our mesh, you will see they are somehow there on the ground. Let's make a custom preview for this mesh as well. And then let's enable only this. And let's change this color. So you can see the differences, okay? Now we go there, and we can remove this contour, so make it easier for you to visualize it. Okay, you can turn off the whole, you cannot, but because it's selected, but you can make it easier for you to visualize. Then you see the walls. So the curves and the walls, somehow there are some embedded, other not. What you can create is a custom visualization for them. Move them here, and so you may need here brep, put the mass, and create a geometry. Now if you want to give them all the same color, that's the same color. You will see here there is a hole, because they are floating. So then is when you can modify your spots if you want. Okay, so let's do that in a minute. But what will happen is that you can maybe merge these ones. Let's try to use merge and then connect this data, and this result goes into one single one. So as you can see, the draw walls or curves can be used interchangeably. And here we are. We have draw all in one single batch, let's say. If you want to differentiate, obviously you need to generate two different ones, but now we're merging. Okay, so now let's try changing these heights to see how this wall behaves. So let's change this height. As you can see, the bottom of the wall will definitely modify and increase. So let's make very dramatic this thing. And then we're creating here, for example, a retention wall or a dam, correct? Um, but we may not need to do it, so leave it there. And you can also change the height of the other one and see what happened. The wall is automatically updated. So with this option, you can change also the heights of the wall along the whole curve or polyline. And you can have walls with different heights. So it's super useful when you are a landscape architect and you want to generate different sort of heights and walls all following different curvatures, or for example a spiral wall that goes up like this one, and you want to have different heights for your points. You will see here the wall behaves quite well. Now the wall here in this very moment hasn't interacted with the topography yet, as well as the curves. So here is where it happens that once you have created these walls and 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 curves, then you can use them to modify your topography. So grab the topography. Let's create another of these titles to make it very clear. Create walls and curves. Yes, don't forget to save time to time. So what we're gonna do here is there is here this gray topo option allows you to modify. There are also modify tools for those who are by the Pro, which is not in my case right now, but you can have this list. And this allows, look, walls, path, stairs, curbs, etc. So we just grab this sort of merge result of the masses, and we can plug them there. Sorry, it didn't work. I think it's this one. Yeah. So we just grab this merge result of the instances of the wall and the curves, and we plug in. And notice how the terrain has completely changed. Look at carefully. We plug it there. So the topography is being modified in order just to match follow those walls and curves. It's a huge modification. Then is when you can start playing and saying, okay, I don't want this. Disconnect. Okay, we can disconnect here. And then reassess here your options and say, no, these 2 points and these 2 points are too high. So we can reduce them. And we can do the same with these two, reduce it slightly here. And then plug there and see how the terrain is not dramatically changed. You can continue playing with this or add more number of points or breaks along the curve if you want to modify it in a specific way or you want to follow. This is just an exercise, but obviously you need to do this more accurately. The same happens with the curve. You can modify here the curve, and this curve will be definitely adjusted. I suggest you to do these modifications with the points. You could always use a display option or move of the VREP. You can move the VREP, but this is easier. And then, well, you have curves and walls interacting with your topography. Okay, so this is where this point will make a significant impact in the topography because it will modify. And so here I'm creating a sort of dam. So it's very important that because these points are used to create a new Delano mesh. So that's how it is create topo with features and how you can use these features to modify, including the boundaries and break lines, but also features such as walls, spots, and curves. And I hope this video tutorial has been also useful for all of you to create very interesting topographies. And this is, I think, of great help to landscape architects and architects or designers who work in outdoor spaces and want to modify the topography. So in our next tutorial, we will focus on paths and stairs. And in future, we will focus on plan kit and pavement kit. So stay tuned. And thank you very much for being here today. Stay safe. Take care. Bye.